So in last class we discussed about what? About this one. Dalton's atomic theory. है ना? So Shazan, do you know what is Dalton's atomic theory?
No, ma'am. I wasn't there. I might don't. I was not there in the last class.
So why?
Ma'am, I think I don't remember.
You don't remember? Okay.
Why I was.
Okay.
I was not.
Good evening, ma'am.
Good evening, Razi. So he gave these theories. The first one is all matter is made up of very tiny particles, which is called what? Atom. है ना? Second one is atoms are indivisible particles which cannot be destroyed or created in a chemical reaction. And third one was atoms of a given element are identical in mass and chemical property. Let's say this is my beaker, and here in this beaker I have lots of He helium. So if this first helium mass is equal to the second helium, hai na, it's not like like this helium is having 2 mass and this helium is having 3 mass. No, both the helium will have same mass only. Yes sir, hai na? So they are identical in mass and chemical property will also be same for both the heliums. And if we will talk about the helium and hydrogen, then what will happen? The mass will also be different and the chemical property will also be different, right? Okay. Fourth one was atoms of a different elements will have different mass. Razi, getting it now? That day we already discussed.
Yes, ma'am.
So atoms of different elements will have different mass. It means like if I am taking example of sodium and chlorine, so both will have what? Different mass and both will have different chemical properties. And if I'll take both sodium and sodium, then obviously these two will have the same property and the same mass. है ना? So fifth one was atoms combine in the ratio of a small whole number to form compound. Now Shazan will tell me ki what is a whole number. Come on, Shazan, tell me what is a whole number.
Now you're asking what is whole number? Okay.
Whole number.
Ma'am, whole number are number which does not consist of fractions.
Zero is a whole number?
Yes, ma'am, it's a whole number, ma'am.
2?
Whole number. Yes, ma'am. Whole number consists of all integers.
Okay. So this point is saying that the atoms combine in the ratio of small whole number to form compounds. It's not like we will combine H2 by 3O. No. Right? Water molecular formula is H2O. Means 2 is what? 2 is a whole number here. And if we will write 2 by 3, then it will be what? It will be a fraction number. Hai na? It will be rational one. Like here, one a numerator and below the denominator is there. That's why it's saying the atom will always combine in a whole number. If I'm writing Na2SO4, so here in place of sodium, it's 2. It's a whole number. And in this SO4, it's what? 4. Hai na? 4 is also a whole number. It's not like I'm writing 4 by 7, 2 by 9. No. The atom is there only in the whole number. Okay, so these 5 theories was given by this scientist. Okay, and the last one is the relative number of kind of atoms are constant in a given compound. It means if one H2O is there, H2O is what? H2O is water. So if we'll take, let's say, if we will take salty water, if we'll take cold water, any water if we are taking from anywhere in this world, it will be H2O only. It's not like it will change to H3O, H7O. No, it will be same. It will be constant. Hai na? So this was the 6th one. Now that day you guys told me to make you understand that drawbacks. Hai na?
Yes, ma'am. Limitations of Dalton's theory.
Drawbacks. Okay, so let me explain. Where should I write here? Drawbacks of Dalton's atomic theory. Now, first one. So, according to Dalton's, atom were indivisible, hai na, which cannot be divided, right? See this point here. This one. Second point. Atoms are indivisible particle which cannot be divided further. So this theory was given by this Dalton one. So first let me write the theory that according to atoms were indivisible which cannot be divided. But here the drawback is, any guesses? Now,
Yes, ma'am.
I
Ma'am,
think we can, ma'am. I think because like you can break them down into like electrons, neutrons, protons,
yes, very good. Atoms are further divided into
and
three
you can
particles,
also
right?
make it up to,
And
and you
the
can make,
neutrons, protons, and electrons,
Ah,
ma'am. And each of them
atoms.
yeah,
have
and
charges
neutrons
and
and
then
protons
exactly.
you can also break up into quarks.
Hmm. Three particles, which is first one is electrons.
When they're negative charge, when positive charges and protons, and then
Proton and
neutron
neutrons are
is neutral.
neutral
Protons
charge.
and yes. So this was the drawback of Dalton's theory, that he told ki, your atom were indivisible and which cannot be divided. But the drawback is your atoms are made up of three particles, which is divided into three: one the electrons, protons, and the neutrons. Here in the middle one there is two things: protons and neutrons, है ना? And electron revolves around these, right? Yes, yes.
Yes, sir.
yes, ma'am.
And what about the second one? Second drawback is he told that atoms of an element will have exactly same mass. है ना? Will have exactly same mass. Here means we already discussed na ki that two helium will have the same mass. But if we will talk about helium and sodium, these two will not have the same mass. So here in this point also there is some exception. If let's say I am taking carbon, do you know what is isotopes?
Yes, ma'am. It has like the same mass but different like properties or something. Like carbon 12, carbon 13, like that, I think.
Yes, same number of protons but different number of neutrons.
Yeah.
Okay, same number of protons but different number of neutrons. So here neutrons. So here the drawback is carbon mass number is what? It can be 12, it can be 13, it can be 14 also. It's not like it's same that only carbon mass number is 12. No, it can be 13, it can be 14, and it can be 12 also. Okay. So this theory also was wrong. Okay.
Yes, ma'am.
Third one. What about third drawback? Any guess? Third drawback. That atoms of different element will have different masses. है ना? Different masses. We studied na about helium and hydrogen, both will have different mass. But let's take mass number of argon and calcium. What is the mass number of argon? Come on, fast. Mass number of argon. Anybody?
34.
No. Yes, Shazan.
Ma'am, 13.
No. Aram, where's your periodic table?
So
Ma'am,
it's like
40,
13,
40, ma'am,
40,
40,
40,
40.
40, sorry.
Google. Okay.
No, ma'am, I have periodic table.
Oh. And what about calcium?
Calcium,
Wait.
40.
Yes, 40. So see, here
Oh,
also
40.
this theory is wrong. That he told that atoms of different elements will have different mass. But here, okay, we are taking different elements. Argon and calcium are both are different elements, but they are
But
having same
argons,
mass.
but argons means that accurate is 39 point something, means that is
No,
approximately.
that's taking approximate because there's many isotopes of argon,
Yes,
right? So it's taking the approximate.
I told you the approximate value for argon is 39 point something,
But
which is very close to 1, means 40 something.
yeah, but it's ma'am is asking this one, right? In argons there are many there's like isotopes, so it's taking the average. So mostly it's 40.
So got it?
Yeah.
So these three are the drawbacks. First one was according to Dalton's, the atoms were indivisible. But here the drawback is that the atoms are made up of three particles: the electrons one, proton, and the neutron. Proton and neutron is there in the middle one, and the electron revolves around the proton and neutron. Okay. Second one is atoms of an element have exactly same mass, but carbon mass number is 12 also, 13 also, as well as 14 also. So this was the drawback. And the last one was that the different element will have different mass, but here argon and calcium is having the same 40 mass. Okay, so these were the drawbacks. Now let's talk about this. This also we already discussed, hai na, ki what is atom? Atom is what? It is the smallest unit of matter which may or may not have an independent existence but always take parts in a chemical reaction. It means what? If I'm writing H2O or if I'm writing CaCl2, so here is what? 2 and 2. it's they are taking part in this whole chemical formula, right? They may not have its own independent existence, but they will combine, है ना? So here atom is combining means H2O. Here also atom is combining. That's why I'm writing CaCl2 over here. I can't write CaCl2 as 2. No, है ना? Because atom is not having its independent existence. It will always take part in a what? Whole chemical reaction or whole chemical formula. Next was what? The atomic radius is measured in what? Nanometer.
Nanometers.
NM.
Nanometer.
Yes. And what is 1 nm? NM is what?
Ma'am, 10 to the power minus 9
Just 9.
meters.
10 to the power 1. 10 to the power minus 9. So second one was what? So these were, first one is here. And these are what? These are the modern day symbols. And we already discussed that. For carbon, we will write like this, like whole black thing in a circle. Oxygen is this, phosphorus is this one, sulfur plus sign, iron, mercury, platinum. And these are the IUPAC name. This is what? The first letter of a symbol is always written in a capital letter and second as a small. Like if I'm writing, let's take example of aluminium. Aluminium, A is what? We will write A as a capital letter and the second one is L, which will be in a small letter, है ना? AL. The second one was the symbols of some elements are formed from the first letter of the name and a letter appearing later in the name. Any example, Shazan?
Ma'am,
Ma'am, zinc. Ma'am, manganese.
I'm like, what is this? Zirconium?
What are them?
Zirconium? I don't know how to pronounce it. Zirconium?
Chromium.
Nobium?
Cr.
No, yeah, Zr and B. Nobium.
Zinc is also there because why? The first letter is coming and after that the later appearing later.
argon also.
Huh?
Argon is also there.
Hmm.
And chlorine.
Chlorine,
Argon,
yes, chlorine is written
sir,
here.
ma'am, argon is not it's argon is AR, but it also starts with AR.
What?
Argon is, it's not argon.
Madam,
Argon, I'm like rubidium, RB,
RD.
RB,
RB.
yes.
ma'am,
it's
bromine
also
also.
Strontium.
All are correct. Okay. Third one is what? The other symbols have been taken from the name of elements in Latin, like iron, which is Fe, sodium, which is Na, potassium, which is K. Any more examples?
Not able. And there are many.
Tell me,
Yes.
na. You want.
Sodium.
No.
Iron.
What about gold?
Gold AG.
What about silver?
Gold. Mercury, I think.
Mercury also, which is H, na?
Yeah.
Yes.
HG. Gold.
Gold is AU, AG.
AU.
Silver, AG?
Yes.
Yeah.
Yes. So these are the examples. Now, what is this? This is also same. Iron came from
I
this.
found a new example of like it includes the second letter, like
What?
both the letters, like magnesium. I found an example like that.
Magnesium.
Yeah, just like that. It's
Magnesium
like
is Mg, na?
it's the second letter. The letter, like the second letter comes somewhere later in the name.
So?
Yeah, I found a lot of examples yesterday and I wrote it in my notebook. When I remember, it was like Tennessee.
What, 10?
Like the second last element, Tennessee. I don't know.
What item? Tennessee? What is Tennessee?
Like the second last element.
Okay, let me check. What is second last element? C. This one?
Yeah.
PS. This also. No, this also. This. No. This one also. This one also. Lots are there. No? Many are there. Okay?
So
Now. So here your iron came from this Latin word which is ferrum, gold from Latin, chlorine from Greek, cobalt from German, sodium from Latin. Okay? Ferrum, aurum, calcium, chlorus, cobalt, and natrium. Now, what about this? What is 1 AMU?
Ma'am, it's one atomic mass unit and it's used to measure the weight of one atom.
Okay. What is the value of 1 AMU?
Ma'am, like, I'm not to understand the question. Like, what should it be equal to? Like, In what units?
kg.
Ma'am, may I?
Ma'am, that'll be very small. Ma'am, like very, very small.
Can I?
Tell.
Ma'am, it's 1.6 into 10 to the power minus 27 kilograms.
Yes. So AMU is what? Atomic mass unit, or we can say U also, which is unified mass. Is the standard unit for measuring atomic mass. And what is your atomic mass? 1 AMU is 1.67 10 to the minus 27 kg. Carbon 12 isotope was chosen as the standard reference for this, for atomic mass unit. And your 1 AMU is a mass unit which is equal to 1 by 12th mass of one atom of carbon 12. This is what? 1 by 12th mass of one atom of carbon 12. Your 1 AMU is 1 by 12th mass of one atom of carbon 12. Okay? And here, these are what? Some symbols of some elements. These we already know that symbols and all. Let me write some elements and some relative atomic mass. What is the atomic mass of carbon? Carbon, nitrogen, oxygen, sodium. Come on, tell me.
Ma'am, for carbon it's 13.
13.
Yeah, means 12. So 13, 12, same only.
But mostly we use carbon 12 only. है ना?
Yeah.
What about nitrogen?
Nitrogen, it is say 14.
You all have to learn these.
Ma'am, I know that
Atomic-
oxygen
In the
is
first
8.
30 we need to.
Ma'am, oxygen is 8.
Oxygen?
8.
8.
8, ma'am.
Ma'am, for sodium it is 22. Means
No, oxygen is 8.
Ma'am, oxygen is 8.
Sorry,
16 na.
sorry, 16. Are you are
Atomic mass is 16.
Oh, ma'am. Okay,
Okay.
so ma'am, atomic mass is
ma'am, for sodium it is 23.
Sodium is 23, magnesium 24,
20,
aluminum 26. See
magnesium
this. Let's
24,
1 minute.
aluminum is 27.
See this periodic table. Here, where's my nitrogen? See, this is my nitrogen. है ना? And the atomic mass of nitrogen is, this is the atomic mass, okay? Relative atomic mass. So here, your nitrogen atomic mass is how much? 14, okay? What about aluminium? It's 26.
127.
So we will take approx 27. What about magnesium? Where is it?
Magnesium is 24.
It's 20.
4.
Sure.
Yes.
Okay, yeah, it's 24. And what about helium?
What?
Helium.
Helium 4.
4. So you all have to learn this, huh? Till up to 20, up to 50. Up to 50 is must. Okay? Now, next. See, here also it's written what is relative atomic mass. It is defined as the number of times of a given atom which is heavier than this of mass of one atom of carbon 12 and on its average mass of the atom as compared to 1 by 12 of what? Of carbon 12. है ना? What is atomic mass unit? It is defined as the mass unit which is exactly equal to 1 by 12th mass of what? Of carbon 12 isotope. Now, what is molecules? What is the definition of molecule? Come on, anybody. What is molecule?
Like a molecule is like just a collection of atoms.
It is
Like UO2HPO4.
Ma'am, a group of atoms.
what? Smallest particle of an element. Smallest particle of an element, or we can say compound.
So
That
I
is
just
what
just write compound.
that is capable of an independent existence and shows all the properties of that substance. That is capable of an independent existence. First, let me write the definition. Things
Here
and
is one example.
shows. What is this?
UO2HPO4 4H2O.
Anybody know how to solve that electronic configuration for question? Like 1, 2, 2, 3. No?
No, ma'am.
What is that electronic configuration question?
Electronic configuration. I'll tell you later. Okay? First, see what is molecule. It is defined as the smallest particle of an element. It is what? Smallest particle of element or a compound that is capable of an independent existence. Let's say I am writing H2. H2 is a combination of 2H, right? It is what? This H2 is capable of its own independent existence and shows all the properties of that substance. Means if here I'm combining 2H, which is combining and forming one hydrogen, then it is what? It is showing the property of that particular substance, of that particular hydrogen substance. Okay, this is what? This is reactive. These two reacts to form what? To form H2. If I'm writing HCl, here H is combining and Cl is combining. Means two molecules are combining to form, sorry, two elements are combining to form one molecule, right?
Yes,
Here
ma'am.
also two elements are combining. Hydrogen elements are combining to form H2. Here hydrogen chlorine is combining to form HCl. If I'm writing NaCl, then here also Na and chlorine is combining. Two elements are combining to form one molecule, NaCl, which is salt. Okay, so it is what? It is a group of two or more atoms that are chemically bonded together. It is a group of two or more atoms that are chemically bonded together. It is a group of two or more atoms. It means what? It means H and Cl. This is what? This is a group of two or more atoms which are chemically combining to form one molecule, HCl. Okay? Okay. Here, the smallest particle of an element compound which is capable of independent existence and shows all properties is known as, is called as molecule. Same definition. Molecules can be divided into two categories. Okay. Okay. First, molecules of element. The molecules of an element are constituted by the same. Here, the molecules of an element contain same type of atoms. Molecules of many elements are made up of only one atom of the. Like here, if I'm writing noble gas like argon, helium, helium is what? Only He. Argon is what? Only Ar. And here only one atom is combining. It's not like argon and chlorine is combining. No, only one thing is combining, which is argon. And for helium also, which is He. Means only for noble gas, only one thing is combining, right? 1 second. Sorry, yes. So here for noble gas, only one thing is combining, argon, helium. And the molecules of most of the non-metals are made up of more than one atom, which is oxygen, means 2O2 is combining, O3, 3 oxygen is combining. Hai. So this is of two types. One is your noble gas, which is only one element, and another one is which is combining, like which are bonded, two or more elements are bonded to form a one molecule. Okay, what about ozone? Ozone layer is O3, means here three oxygen are combining. Now what is atomicity? It is defined as the number of atoms. Atomicity means it is defined as the number of atoms which is combining to form a molecule. Number of atoms combining to form a molecule, like one atom, two atom, three atom, four atom. So this atomicity is divided into 5 types. Mono is 1, di is 2, tri is 3, tetra 4, poly 4, 5. If I'm writing all the noble gas are monoatomic or diatomic molecules. All the noble gas are mono or di. Tell me, one atom or two atom? Your
Ma'am,
argon.
one.
So it's mono or di?
Ma'am,
Mono.
mono.
Mono. Your noble gas is what? Argon is only Ar. It's not Ar2. Helium is only He. It's not He4. No, right? So all the noble gas are monoatomic molecules. And what is atomicity? Atomicity means that how many number of atoms are combining to form a molecule. Number of elements to form a molecule is known as atomicity. If only one atom is combining, means that all belongs to a group of noble gas. What about diatomic? Here like H2, O2, N2, I2, Br2, Cl2, HCl, NaCl. It means C, and HCl is also diatomic. How? Because here two atoms are combining. One is hydrogen, another one is chlorine. NaCl is also di because sodium and chlorine is combining. Okay? So this is diatomic molecule. Now what about tri? Tri means three are combining. Here your ozone is three. Your CO2 means your one carbon and two oxygen combining. What about tetra? Tetra means four. Your H2O2, your potassium, four. Poly means five. S8, CH4, all are what? Polyatomic. So molecules are nothing but your elements which are combining, which are chemically bonded to one another to form a one whole molecule. Means elements are combining to form a molecule, and molecule is divided into two parts. One is that one is what? One is that it will contain only one atom, means all the noble gas, and the second one is what? It will contain more than one atom, and more than one atom is what? Is dia, tetra, tri, and polyatomic. Now you tell me that what is NH4Cl? This is no, not NH4Cl. What is HCl? HCl is mono, di, tetra, poly, what?
Ma'am, I think mono. I think
Mono? Okay, mono.
and
Arham, what
the
about
second
you?
one, which is
It's mono, di, tetra, what?
yes, ma'am.
Ma'am,
Okay, wait.
I think
Okay, wait. For Razi, it's mono. For
No, ma'am, it's di.
Acha, for Razi, it's
mono.
D. For Arham, it's mono. And for Shazan, what about you?
Ma'am, for me also it's ma'am, I think it's tetra. No, not tetra.
Tetra. Okay.
Ma'am,
Now
no,
let's
no,
check. HCl. Now you can see. What is HCl? Razi is correct.
die.
Di, obviously di na. Why di? Because here two atoms is combining hydrogen and chlorine, so it will be di. If I'm writing O3, O3 is what? Is tetra.
Right.
Why? Because
Sorry,
three
tetra.
oxygen are combining. And what about argon?
Mono.
Mono, because only one element is there. है ना? It's logical only thing. Now, if I am writing H2O2, it's what? It's poly, tetra, what?
H2O2.
It's the fourth one. Mono and what
Here,
was that one? I cannot remember the name of fourth one.
what? Tetra.
No, that like after four.
Yes, ma'am.
No, there are.
After that.
Poly.
Yeah, poly.
But it's not poly. It's four
It's
na.
four, but-
What is H2O2? H2 means 2H. O2 means 2O. Means
Yes,
total is what? 4. It's what?
Ma'am, before that one, the five one, ma'am, the fourth one, yes,
Yes,
ma'am,
ma'am.
it's tetratomic.
Tetratomic molecules.
Okay. Now you understood what is poly, dia, tetra.
Yes, ma'am.
Okay. Only one atom. All the noble gas will be mono. All the two atoms, if two atoms will combine, then it will be di. 3 tetra, 4. Sorry. 3 tri, 4 tetra, and more than that, it's poly. Okay. More than 4 elements, it's poly. If I'm writing, okay, let me write Na2SO4. Now you tell me.
Ma'am, it is poly.
Yes, it's poly because here 2 sodium, and for this total is what? 6. More than 4 is poly. Okay? More than 4 is poly. If I'm writing CaCl2, come on, CaCl2,
I'm
tetra.
no, ma'am. Try.
Try, because one calcium and 2 chlorine. Okay.
Why?
And what are them?
It's tetra, right?
No, why tetra? 3 na. This is 1, this is 2, so it's 3.
Yeah, this one. Oh, yes, but
Try na. Tetra
Yes,
means
ma'am.
4. Okay,
Oh,
now
try.
let me ask Arham.
I keep on forgetting.
NaHCO3. Arham will tell.
7.
7. See, 1 sodium, 1 hydrogen,
And 1,
carbon 1,
4, 5.
oxygen 3.
Wait 1 second. 1, 1. So 6.
So, mono, di, tetra, tri, what?
Poly.
Poly. Good. Poly, right, Razi?
Yes, ma'am.
Oh, so now you guys can tell the atomicity of any molecule, है ना? That whether it is mono, whether it is dia, whether it's tri, tetra, or poly. Okay. So this is also see. This is also what? These all are mono. All are noble gas. Sorry. No, here ozone is also there. This is what molecules of compounds means. This is your compound. Your H2O is a compound. NH3 ammonia is compound. And what is combining element? Hydrogen and oxygen. Your ammonia is NH3. And what is combining element? Here, nitrogen and hydrogen. CO2 combining element is carbon and oxygen. Now, Arham will tell that NaCl combining element is what? This thing is combined.
Yes.
This whole thing is combined. Now, what is the combining element of these combining element? Okay, Razi, what is the combining element of this molecule?
Sodium and calcium.
Sodium and chlorine, na?
Yes, ma'am. Chlorine.
Sodium and chlorine, Arham. This is sodium, this is chlorine.
Oh.
C. What about CO2? Carbon and oxygen.
And carbon.
H2S, hydrogen and sulfur. It's easy. Means this is your compound and which is your combining element. Combining element means the two elements will combine to form one compound. What is common salt? See, NaCl means sodium and chlorine. Your NaOH means N. Okay, wait. Arham, tell me. NaHCO3 combining element is. Okay, anybody tell me.
Ma'am, like, what was sodium,
Ma'am, it is sodium,
sodium,
hydrogen,
hydrogen,
carbon.
carbon, and oxygen.
Sodium, hydrogen, carbon, and oxygen. Yes, sodium, hydrogen, carbon, oxygen. So here also CaCO3 means calcium, carbon, and oxygen. Okay. So these are the combining elements. This is the mass ratio. Your water ratio is 1:8. Now these are what? These are the ratio by mass. This is what prediction of number of atoms of mass ratio. So here by nitrogen mass ratio 4, hydrogen is 3, atomic okay, mass ratio is this, atomic mass is this. So how to find mole ratio? Mole ratio means your mole ratio means mass ratio by atomic mass. Wait a second. Your mole ratio is mass ratio upon atomic mass. Now, what is your mass ratio is for nitrogen is 14 and the mole ratio for nitrogen is also 14. Means it will be 1. So if I am okay, let me ask about chlorine. What is chlorine mole ratio? Tell me. Calculate and tell me. Anybody? Mass ratio to mass. Okay, so this is your homework. You have to find the mole ratio of this one. Okay, so in the next class, we will talk about this ion. Now, the next one is what? Formula of simple compound. Then after that, molecular mass, and that's it.